السلام عليكم ورحمة الله. This lecture talked about thyroid gland, thyroid metabolic hormones. As you see in this figure, this is thyroid gland. It's composed of two parts, right lobe or the right part and left one. It's located beneath or under larynx and above or in the anterior part of trachea. As you see in this figure, this is the front view and this is the back view. In the back view, we can see the parathyroid gland, 4 parathyroid glands in each side or in each corner of the thyroid. So, thyroid gland located below the larynx and in the anterior part of trachea and secrete thyroxine, T4, triiodothyronine, T3, and calcitonin. Secretion of these hormones by or controlled by thyroid stimulating hormone, the hormone secreted from anterior part of the pituitary gland. Synthesis and secretion of thyroid hormones. Thyroid gland is about 39% of its secretion is T4 and only 7% T3, but the most of T4 can convert it to the T3 in the tissues, in the target tissue. There's a difference between rapidity and intensity between these two hormones. How? T3 is about 4 times as potent as T4. Despite of T4 have much or more amount of quantities, but the effect of T3 is much power. In the blood, the T3 is smaller quantities and persists for shorter time when compared with T4, but it has the much power active in the tissues. Physiologic anatomy of thyroid gland. Thyroid gland composed of larger follicle of follicles filled with colloid, and these follicles lined by, we can explain on the figure. This is a follicle. This is a follicle. This follicle, as you see, is enveloped or is covered by a line of cuboidal cells. These cells co-secretory. Why? Because it's able to excrete of materials in the center to permit to get out, to excrete it to the blood vessels. So the follicles filled with materials called colloid, composed of thyroglobulin, and is enveloped by one layer of secretory cuboidal cells. Iodide is very important material to form thyroid hormones. So from where we can get iodine, we can get it from food. To form normal quantities of T4, we need 1 milligram per week of ingested iodide, but not in the form of iodine, but in the form of iodides that require to synthesis of thyroid hormones. Normally, most of iodides are rapidly excreted by the kidney, but only 1/5 of its amount that's bring from food, only 1/5 used for synthesis of hormone, and the other 4/5 amount excreted by the kidney. Thyroglobulin and chemistry of T4 and T3. Endoplasmic reticulum and Golgi apparatus able to synthesize and secrete of large glycoprotein molecules called thyroglobulin. So follicles filled with colloid. The materials in this colloid is called thyroglobulin. What is the thyroglobulin? It's a glycoprotein material. From who is give the follicles thyroglobulin? Who is the synthesis thyroglobulin? This material synthesized from or secreted from endoplasmic reticulum and Golgi apparatus. Each molecule of thyroglobulin composed of 70 tyrosine amino acids. It's a protein, glycoprotein. Part of its structure is protein. This protein composed of 70 tyrosine amino acids. As regards the major substances that combine with iodine in the form of iodide, of course, to form T4 and T3. And when the body needs hormones, there is a connection or attachment or combination between iodide and tyrosine. When there is no need for these hormones or there is enough amount in the blood, tyrosine will be stayed in its free shape in the follicles. This figure showed this is a colloid materials have thyroglobulin, cuboidal cell, and blood vessels. We must note that the blood vessels and the thyroid gland is very more because it has lots of blood to provide hormones to all the cells. As we said in the first lecture, the thyroid hormones regard one of the general effect hormones such as growth hormone. So most of the cells in the body need thyroid hormones to do its activity very well. So we need lots of blood vessels to provide each cell in the body with these hormones. Colloid material have thyroglobulin. When these materials enter by endocytosis to the cuboidal cells, lysosome will act on it to release T4 and T3 by lysis, and these hormones can enter blood vessels by diffusion. In the cells, there is increase in concentration of these hormones and low concentration blood vessels. So these materials transport from high concentration to low concentration and then enter to the blood vessel. Blood vessels have another role. It's the part that provide iodide. It can to bring iodide from the intestine, from the food. After absorption, this material can bring it to the follicular cells. So it provides iodide by diffusion also to combine with the tyrosine will release from follicles of thyroglobulin to synthesis of T3 and T4 hormones. Storage of thyroglobulin. After synthesis of these materials in the colloid, thyroglobulin have about 30 molecules T4 and a few molecules of T3. But this is not a problem because T4, as we said before, when they reach to the tissues, to the target tissue, most of T4 convert to T3 to do its work. And have storage materials or storage amount sufficient the body with these hormones enough 2 to 3 months. Transport of T4 and T3 to the tissue after synthesis in the colloid, synthesis of thyroglobulin by Golgi apparatus by endoplasmic reticulum. We said thyroglobulin is a glycoprotein materials, have protein, that means have amino acids, especially tyrosine. Tyrosine with the presence of iodide can synthesis of T3 and T4. Then by diffusion, T3 and T4 can secreted from follicles via the follicular cuboidal cells to the blood vessels. So when these hormones T3 and T4 enter to the blood, bound to plasma protein. In the blood, over the 99% of T4 and T3 combines with the plasma proteins, mainly with thyroxine binding globulin, and less amount with thyroxine binding prealbumin and albumin. So when these hormones enter the blood vessels, they are directly attached to the plasma proteins, mainly with the globulin protein, and in lesser extent with albumin and pre-albumin. Blood vessels take these take these hormones that they carried by plasma proteins to the target tissue. T4 and T3 are released slowly to the tissues. After they reach to the tissue that they want to act on it, they release slowly. Why slowly? Because, because of high affinity of the plasma binding proteins for these hormones. T4 released to the tissue cells slowly. Half releasing T4 is about every 6 days, whereas half T4 only 1 day because it's lower affinity when compared with the T4. On entering the tissue, both hormones again bind with intracellular proteins, T4 binding more strongly than T3. Therefore, they are again stored, but this time in the target cells themselves, and they are used slowly over the period of days or weeks. We can abstract this paragraph. After synthesis, these hormones and enter to the blood vessels. They can move in the blood vessels by attachment of these hormones with plasma proteins. Mainly, which type of protein in the plasma? Globulin. And then, which type? Albumin and pre-albumin. Okay, they attach with these proteins, and this blood carry them to the tissues. What happens in the tissue? They can release from plasma protein slowly because there is affinity of binding. Of course, this affinity is different from T4 and T3. T4 is more affinity to binding with the plasma protein, so it's need about 6 days to release to the tissue. While T3 is less affinity binding, so it can in only 1 day releasing from plasma protein and enter to the tissue. When these hormones enter the tissue, they don't become in the free form, but also in the binding form. They again binding or attached with the proteins in the cell itself, in the target cell itself. So again, they become in the binding form, not in free form. And in this case, the binding form of these hormones make them able to stay active for long period, and the excretion of these hormones will be less. So they are able to act slowly, reach to the period of days or weeks because the binding state of hormones. Duration of action. Okay, these hormones can reach to the target tissue. What happened in the target cells? 2 to 3 days is long latent period before activity, begin after T4 injection. This example that when the person take T4 thyroxine from outside as drug, for example, it required about 2 to 3 days still inactive till be activated. So it's called latent period after injection. Once activity does begin, it increases progressively and reach to 10 to 12 days. Thereafter, it will be decreased with a half-life about 15 days. Then, some of the activity persists for long period, so 6 weeks to 2 months. So, after the person take hormone, we take this example to able to study the period of activity of these hormones when enter to the body. The person doesn't have normal secretion of or have deficiency in the secretion of thyroid hormone. So after injection, T4, we said T4 is the main source of hormones, of thyroid hormones, which is then converted to T3. So the source of thyroid hormones is T4. So after injection, T4 take up a latent period from 2 to 3 days. After 3 days, it's become activity. This activity reached to the maximum activity about 10 to 12 days. So the curve become in the higher point after 10 to 12 days of activity. Then it will be decreased slowly to reach to the 15 days. After 15 days of injection, the effect of activity persists, stay in the same power, and the fixed power till reach to 6 weeks or to 2 months. بمعنى لو رسمنا curve احنا after starting point للكيرف هي moment of injection. So the curve will be stay in the horizontal line for 2 to 3 days, then begin to rise up to reach the higher point. This is occur in 10 or 12 days in this range. What happened in this point? This point represents the power effect of hormone after ending of latent period. So the curve will be decreased, little decrease for 3 days only to the 15 days. If we said it's reached priorly in 12, so after 3 days only, little decrease in its activity. Then the activity will be stable in this range for about 2 months, as most prolonged as possible. 2 months. Physiologic function of the thyroid hormones. Thyroid hormones increase transcription of large numbers of genes. That's why we said it have a general effect. Transcription of genes occurs in all type of the cells in the body, so it has an effect on all type of the cells in the body, such as growth hormone, of course. This causes either increase or decrease in transcription of genes that lead to formation protein, thus producing thyroid hormone response to the cell. This figure summarizes the effect of thyroid gland after secretion. So T4 in the blood, after secretion in the blood, reach to the tissue the cytoplasm convert to T3. T3 enter to the nucleus, effect on the DNA, on transcription exactly, to formation RNA, messenger or mRNA, and that will be effect on the more than one activity of the cells. It will be increase the sodium potassium pump, increase mitochondria and respiratory enzyme, the effect of them. It lead to increase or decrease other enzyme proteins that depend on the type of enzyme, and lead to protein for growth and maturation because of transcription that lead to also synthesis of proteins, and that lead to cardiac output ventilation, increase of both, because that cause increased consumption of oxygen, which increases by effect of thyroid hormones. Also, increased food intake or increased mobilization of endogenous carbohydrate, fat, proteins, source of energy, that by under effect of all these substances lead to increased oxygen consumption for energy, also that by these two hormones. In addition to that, increase of respiratory enzyme or mitochondria or effect of protein enzymes, all these lead to increase the metabolic rate. So T4 and T3 increase metabolic rate, and this effect lead or need increase carbon dioxide, increase ventilation, increase urea, renal function, muscle mass, and adipose tissue, or the decrease of muscle mass, and adipose tissue. So metabolic rate cause increasing of the first 4 points, and these increasing also, of course, need energy comes from muscle mass, muscle storage energy as carbohydrate, and from adipose tissue, the source of energy also. Thermogenesis increase also, sweating increase, water loss, of course, all these under effect of thyroid hormone. That summarized, we can talk by some of explanation in the next slides. Physiologic function of thyroid hormones represented by an increasing metabolic rate, as we said, about 60 to 100 above normal. So that means when a person doesn't have or have a sufficient in the thyroid hormones, there is the metabolic rate, or there is decrease in the metabolic rate than the normal. Rate of utilization of food, of course, there is excretion more than absorption of foods by deficiency of these hormones. So they are increase the benefit of foods. This hormone increase the protein synthesis, acceleration of growth, excitation of mental process, activity of the most other endocrine glands will be increased. Thus, effect due to increasing the number of mitochondria, source energy in each cells, and increase in potassium, sodium pump in each cell. Enough, we can complete the later slides in the next lecture for easy downloading of lecture. Thank you so much.